Hi, I'm Ms. Cho, and in this video we'll solve rational equations using least common multiple or least common denominator. This is a method that works when you have multiple fractions on each side of the equation. When we have equations involving fractions, there's a couple different ways that we can approach them. So for example, if I had x over 3 plus 5 over 12 is equal to 7 over 24, one thing I could do is I could combine these two into one single fraction and cross multiply, which is a separate video. Or you can say, I don't want to deal with any denominators, so let me just multiply everything by the least common denominator and I'll get rid of them. So I noticed that 3, 12, and 24, I'll share the least common multiple 24 because 24 divided by 3 is a whole number, 24 divided by 12 is a whole number, and 24 divided by 24 is a whole number. So if I multiply everything by 24, then I can start canceling. In my first term, I'm left with 8x. In my second term, I'm left with 2 times 5. In my third term, I'm left with a 1 times 7. So this gives me 8x plus 10 is equal to 7, or 8x is equal to negative 3, or x is equal to negative 3/8. In the same way, if I have a rational equation, I can either combine these two into one single fraction and then cross multiply, or I can just multiply through by the least common multiple and get rid of all the denominators. Let's take a look at an example. In this example, we're asked to find the solutions of the equation 10 over x squared minus 2x plus 4 over x is equal to 5 over x minus 2. To do that, we're going to follow 4 steps. First, we find the domain. Second, we ask, does each side only have one fraction? If no, you can either combine down to 1 or you can multiply through by the least common multiple, which is what we'll do in this video. Third, we solve the equation, and fourth, we exclude any extraneous or undefined solutions that make our denominator 0. That's why we have to find the domain first. So my domain is all x's except what makes my denominator 0. So my denominator, I'm going to factor this actually. This is going to be x times x minus 2. Set that equal to 0. That means x equals 0 and x is equal to 2 are the things I cannot use. And it just so happens that x and x minus 2 are my other denominators, so I'm done with the first step. Second, does each side only have one fraction? No, because I have 2 on the left and 1 on the right. And so because I don't, I have to multiply everything through by the least common multiple. In this case, x times x minus 2 is my least common multiple because it's divisible by all my denominators. So I'm going to rewrite my equation, but multiply every term by the LCM. Now that I've multiplied everything by the least common multiple, I can start canceling. So in my first term, I have an x and an x minus 2, and then in my second term, I can cancel the x's. In my third term, I can cancel the x minus 2's. That leaves me with 10 times 1 plus 4 times x minus 2 is equal to 5 times x. Then with the distributive property, I can simplify by moving all my x's to one side and subtract a 4x. From both sides, and then I have 10 minus 8 is 2. So now I've solved the equation and I have to check, is x equals 2 any of the undefined values? And it is, it's right here. Because it makes my equation undefined, I have to reject it. And my solution is that there is no solution. So I can check this on a graph. Here I've graphed my left side in red and my right side in blue, and it says that I was looking for an intersection at x equals 2, but if I zoom out, I see that x equals 2 is actually a vertical asymptote. So that means they're not actually intersecting, they're just never touching. So there's no solution. Let's try a second example. In our second example, we're asked to find the solutions of the equation 2 over x plus 3 minus 3 over 4 minus x is equal to 2x minus 2 over x squared minus x minus 12. Again, first we're going to find the domain, which means I'm going to set all my denominators equal to 0. But to do that first, I'm going to factor my trinomial. So I get x minus 4 and x plus 3. Means my domain is all x's except what makes my denominator 0. So x plus 3 equals 0 gives me x equals negative 3. 4 minus x equals 0 gives me x equals 4. And then x minus 4 equals 0 is also x equals 4. And x plus 3, we already did that. So that means my undefined values are x is equal to negative 3 and x is equal to 4. From there, I'm going to ask, does each side only have one fraction? And again, the answer is no, I have 2 on the left and 1 on the right. Because of that, I need to multiply everything by the least common denominator. And I noticed that 4 minus x is really just the negative of x minus 4. So I'm going to rewrite this as negative x minus 4. Because if I take the negative 1 times this, I get negative x plus 4, which is 4 minus x. Because this is a negative, subtracting a negative, I'm just going to change this to a positive. And so that means my denominators are x plus 3, x minus 4, and x minus 3 times x plus 4. And that means my trinomial, this is my least common multiple. So I'm going to rewrite this and multiply all my terms by that LCM. Once I've multiplied all my terms by my least common multiple, I can start canceling. So my first term, my x plus 3's cancels, my second term, my x plus 4's, and my third term, all of them cancel. So that means I am left with 2 times x minus 4 plus 3 times x plus 3 is equal to 2x minus 2. I'm going to distribute using the distributive property. Then I'm going to move all my x's to one side. So on my left, I have 5x plus 1 is equal to 2x minus 2. And then subtracting 2x from each side, I get 3x on the left. Subtracting a 1 on each side gives me negative 3. So that means my final answer is x minus 1. Now that I've solved the equation, I have to check if these are if x minus 1 is an excluded value. And because it's not, that means I can keep it. And my solution is x equals negative 1. Let's check this by graphing. I've graphed the left side in red and the right side in blue. And so you can see that there is a point of intersection right here at x equals negative 1, just like we found algebraically. Let's summarize. To solve rational equations by using least common multiple, first we find the domain, and then we check and see if there's only one fraction on each side. If there's not, we can combine until there's only one, or we can multiply through by the least common multiple. And from there, we solve the equation and we exclude any extraneous solutions or values that would make our denominator 0.